Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with a new topic of valence electron. We'll be learning the concepts, the chemical properties, metallic and non-metallic nature of element with respect to the valence electrons. But yes, to understand the new topic properly, we have to learn the last session. That is, we have to revise the last session that we learned about the Bohr's atomic model, where the Niels Bohr, a Danish physicist, explained the causes of stability of an atom in a different manner. You can see here in this picture. He suggests that the electrons revolving around the nucleus are confined to certain fixed orbits. We call them shells or energy levels. Here you can see these energy levels K, L, M, N. We can also write them as 1, 2, 3, 4. We call them shells or energy levels. Orbit closest to the nucleus, which is K shell, has the minimum amount of energy, and the electron present in it is called K electron. Respectively, L electrons, M electrons, N electrons, where N, the outermost shell, will be having the maximum amount of energy of an electron. We also learned about the accommodation of an electron with respect to these shells or energy levels, which was actually given by Bohr's-Bury scheme. That is, each shell has a limited capacity to hold electrons, and each electron tries to occupy shell that has a minimum energy, right? So maximum possible number of electron in a particular shell, that is a K shell with the 2 electron cell, can give only 8 electrons, M 18, N 32. Now let's start with a new session with the chemical properties of element, metallic element, that is the nature of element, and the non-metallic nature of element with respect to the valence electron. But before starting with these topics, let me give you some brief knowledge of valence electron so that it will be more easy for us to go through the topic. So friends, here I write valence electron. Right? What is actually valence electron? It is nothing but the electron present in the outermost shell of an element, right? And how do we get the valence electron? We have few steps. First, we should know the atomic number of the element. Second, we have to make an electronic configuration. Then we have to apply Bohr's-Bury scheme we just understood right now. We can also make the diagram to understand the valence electron. 5. The outermost shell electron, just count and we'll get the valence electrons, right? So these are the few steps so that you can get the valence electron. Now let's understand the types of element with respect to the valence electron. What are they called actually? As there are some element who loses electron from the outermost shell, right? And there are some elements which actually gains electrons from the outermost shell of another element. So in first type, these are called cations and these are called anions. They're actually converted into the ions. This one with the positive charge on it, and this is with the negative charge. Let's take an example. Example of the cation. Let's take sodium, which has the electronic configuration 281 with respect to the Bose-Bury scheme. We minus electron and it will have the ion, that is a cation, with a 2, 8, right? Now if we take the example of an ion, that is the negatively charged ions, we take the chlorine, 287 with the electronic configuration, we add the electron and we'll get this 2888, right? So these are the basically types of elements depending upon the valence electrons, as some gain the electron to the outermost and some loses from the outermost shell of the element. And there are some elements which doesn't gain or lose electron from the outermost. They are called inert gases. They're also called noble gases, right? They don't gain electron or lose electron. Now let's see what are the actually properties of valence electron, what they do to the element. Let's take one more page. Let's see the properties, what they do to the element. First, they are responsible for the chemical properties of the element. Second, they take part in the chemical reaction, that are the valence electrons. In chemical reaction, what happens actually, bonding of elements to form and compound, or you can say bonding of two atoms to form a molecule, right? And how do you represent the electronic configuration of the element and understand the valence electron? Like this. You have to just make circles depending on the electronic configuration. Let's take an example of boron. With 11 be the mass number and 5 is the atomic number. So this is K shell, this is L, and this is M, right? So K shell, let's take an electronic configuration first. For 5 it will be 2 and 3. So here 2 electrons go submitted and there are 3. So this is what the outermost shell is, L for the boron. And what will be the valence electron for the boron is 3. I hope you have understand it properly. So let's start it, the very systematically learning of the session. Friends, what is valence electron? Now you can answer it by yourself, that the electron present in outermost shell of an atom are known as valence electron, and the properties, that is the chemical properties of an element, are decided by the valence electrons, and the valence electrons of an atom contributes to the formation of molecule. So you can see this picture where I have at the right hand side I have a Bohr's atomic model diagram where the valence electron have a highest energy level sitting on the outermost shell, which is actually responsible for the bonding. Here you can see these cartoons. The higher level cartoons have the energy to walk, to jump from outer to inner, from inner to outer, and hence the inners are the most sitting electrons which don't actually move. So let's take an example of a carbon atom so that you can make it more clear. So here you can see the picture of an carbon atom with the proton and neutron at the center of the atom, and the electrons which is actually revolving around the center of the atom in the shells, fixed shells. Let's take a marker. Yes. So this is the valence electron, right? This is the second electron, that is a valence electron. This is the fourth one, or you can also say third one, third, and this is the fourth. Here is the K shell. According to Bohr's-Bury model, K shell is completely filled. This is the L shell, which is partially filled by 4 electrons. So the number of valence electrons are supposed to be the 4, as the number of the carbon, which is the atomic number, is 6, which means that the one carbon atom has 6 electrons. So the electronic configuration of carbon atom will be 2, 4 in the carbon atom. L shell is the outermost shell or the valence shell. So there are 4 electrons in the outermost shell of the carbon atom. Therefore, the carbon atom has 4 electrons as valence electrons. When a carbon atom combines with the other atom, only the 4 valence electrons take part in the reaction. So the 2 electrons of the inner shell of, that is a K shell of the carbon atom, never takes part in the chemical reaction. So hence we say that those electrons of an atom which takes part in the chemical reaction are called valence electron. right? Second point, valence electron are located in the outermost shell of an element, right? So in a chemical reaction, valence electron of an atom are either transferred to the valence electron of the other atom or shared with the valence electron of the other atom, right? So friends, let's now understand the chemical properties of element. That is, the valence electrons of an element having the same number of valence electrons in their atom shows similar chemical properties, and the elements which have different numbers of valence electron in their atom shows different chemical properties. Let's understand it by a periodic table, which is a Lewis periodic table. It is actually the dot diagram and it is a table used for elements, and it shows you how many valence electrons are there in their atom. Here you can see here hydrogen, lithium, nitrogen, sodium, potassium. And second, you can see here the dot that are the actually the valence electrons. In the first group, you can see here that is having only one valence electron. That is it actually proves you that these valence electron elements have the same chemical properties. And if you compare with the second group, which are having the two electrons as a valence electron, they will be having a different chemical properties altogether. Let's understand by this. Like you can see here, three elements: hydrogen, carbon, nitrogen, and oxygen. Hydrogen having the one valence electron, carbon with the four valence electron, nitrogen with five valence electron, and oxygen with the six valence electron. What does this mean? That these all four valence electron of an element have the different chemical properties altogether, right? Now let's understand the metallic nature of element with respect to the valence electron. Let's take a marker. So friends, what does this mean? How the metallic nature of element occurs with respect to the valence electron? Kindly that the elements which have valence electrons 1, 2, 3 in their atom are all metals, right? Except hydrogen, which has one valence electron, and helium, which has two valence electron in a K shell, but they are non-metals. For example, sodium has one valence electron, magnesium has two, aluminum has three valence electron in their atom. So sodium, magnesium, aluminum all are metals. So how do you know the metallic nature of element? First, you should know the atomic number. Let's write down. Let me take a other ink. important. First, know the atomic number, then electronic configuration. Third, let's know the valence electron. Then know, is it 1, 2, 3? If yes, then it's a metal, right? Now friends, let's understand the non-metallic nature of the element. First, 4, 5, 6 or 7. Those elements which is having the valence electrons 4, either 4, 5, 6 or 7 are all non-metals, right? Don't get confused. Let's take a scale 1, 2, 3, 4, 5, 6, 7, 8. Actually these, it is from 1 to 8, but by 8 it is noble gas. By 4 to 7 it is non-metal, and from 1 to 3 it is metal, except hydrogen and helium, right? So now you can understand the whole concept. So friends, let's talk about the special elements. What are these special elements? They are the inert gases which have valence electron 8, that is the fully filled outermost shell. Actually, according to the Borsbury scheme, we should know that the outermost shell of a chemically stable atom can accommodate a maximum of 8 electrons, right? That is, if we call about the stability, the outermost shell should have 8 electrons filled, right? Since all the inert gases have outermost shell with 8 electrons, so they actually don't get a chemical reaction. That is, the all valence electrons are fully filled, so they don't gain or lose the electron from the outermost shell. They are the most stable elements in the nature, right? So now friends, I have completed this session with the concept of valence electrons. Now it's your time to do an activity. Just let me know which are the metals and non-metals in these following elements A, B, C, D, E with the atomic number 4, 10, 11, 15 and 17. Thank you. Now in next session, we are going to learn about the octet rule, which is actually linked to this topic. Thank you.